Now we move from blockchain architecture into execution. You'll take a Besu network design and turn it into a working private deployment, defining Genesis settings, choosing consensus, creating validators and accounts, connecting nodes, and using Docker to keep the environment reproducible. So far, we've built the foundation: Besu concepts, architecture, development, governance, and security. In Module 5, requirements became a network design. In this module, that design becomes a private Besu network, ready for contracts and applications in the next step. The target is a small, controlled Besu network where every node follows the same chain rules. That begins with a shared Genesis file, which defines the network ID, consensus settings, accounts, and initial state. From there, nodes discover each other through a boot node or static peers. Validators produce blocks, while RPC or development nodes let clients interact with the chain. The deployment is working when peers connect, blocks are created, and nodes stay synchronized. A Besu deployment is a set of coordinated settings across nodes. The Genesis file defines the shared starting point, chain rules, initial accounts, and consensus behavior. Each node also needs its own startup configuration, including data paths, keys, ports, and enabled APIs. Networking settings determine how nodes find and trust peers. Validator setup defines who can produce blocks. Accounts and permissioning then control who can connect, transact, or administer the network. The Genesis file acts like the constitution for a private Besu network. It tells every node which chain it belongs to, which consensus rules to follow, how gas is configured, and what accounts or balances exist at block 0. In some networks, it also identifies the initial validators. The key requirement is consistency. If one node starts with a different Genesis file, it is effectively trying to join a different blockchain. The chain ID is the network's identity stamp. It is set in the Genesis file, and every signed transaction includes it. If someone tries to replay that transaction on another Ethereum-compatible network, the mismatch causes it to be rejected. For a private Besu network, choose a unique chain ID that does not collide with mainnet, testnets, or other internal environments. Then ensure wallets and applications sign transactions with that exact value. Consensus is also set at network creation, so every Besu node starts with the same rules. In private networks, validators are the nodes allowed to propose and validate blocks. Clique is simpler and useful for lightweight development. IBFT 2.0 and QBFT add stronger finality and are common enterprise choices. The selected mechanism, initial validator set, and timing parameters directly shape block time, fault tolerance, and overall control of the network. The Genesis file can also prepare the network for immediate use. Through the alloc section, you can create accounts with balances before the first block exists. This lets developers and validators submit transactions right after launch, which is especially useful in test networks and demos. The same file sets operating assumptions such as gas limit, block timing, contract size behavior, and hard fork rules. These choices should match what you are trying to simulate or prove. Once the Genesis file defines the shared network, startup configuration makes each Besu node unique. Give every node its own data directory so chain data and keys do not collide. Point each node to the same Genesis file, but assign distinct P2P, RPC, and metrics ports. The node key creates the node identity peers use to connect. Then configure discovery, RPC access, and logging, start the process, and verify that it joins the network. A Besu node's data path is more than storage. It holds chain data, local configuration, metadata, and the node key. That key creates the public identity, including the node address other nodes use to recognize it. In private networks, especially for validators, that identity must remain stable. If you delete or recreate the data directory, the node may return as a different participant, resetting state and confusing consensus tests. A Besu node has separate doors for separate jobs. Port 30303 handles peer-to-peer traffic, so nodes can sync and gossip. Port 8545 exposes JSON RPC, and 8546 exposes WebSocket connections for tools, dApps, and deployment scripts. Metrics often use 9545 for monitoring. In development, this access is convenient, but do not open everything by default. Enable APIs like ETH, NET, Web3, and especially admin deliberately with host allow lists and cautious CORS settings. Before Besu nodes can sync or produce blocks, they need a way to find each other. A boot node acts as the first known contact, helping new nodes discover the rest of the network. Static peers are simpler when membership is fixed. Each node is given the exact peers to connect to. In either approach, the node URL must be correct: public key, host, and P2P port. Most connection failures come from bad addresses, host names, or blocked ports. These controls move a simple Besu development network closer to an enterprise environment. Node permissioning defines which peers are allowed to join and connect. Account permissioning controls who can submit transactions. Logging provides the evidence needed to diagnose startup, sync, and consensus problems. Operational flags such as debug visibility or sync behavior should be chosen deliberately. The goal is not maximum restriction or maximum noise. It is the right balance of access, insight, and simplicity. Docker makes a Besu network reproducible on demand. Each container represents a node with its own data volume, ports, and startup command. Docker Compose captures those pieces as code, services for validators and RPC nodes, a shared network, mounted Genesis configuration, and peer settings. With that in place, every teammate can run the same network with one command, then tear it down, rebuild it, or adjust topology without manually reconfiguring each node. You've now taken the architecture from design into execution. A shared Genesis file gives the chain its identity, and each node adds precise paths, ports, RPC, and peer settings. Docker makes the setup repeatable. Next, you'll connect smart contracts and applications, then assess what production readiness really requires.